I'll just put reminder as well. Okay. So hello everyone. So good evening to all, and good evening to you, sir, as and this is the first session of Indian Space Week, in which we have been put in the three scientific sessions, and this is the first session of that. And in this week, we are just going to do lots of things. So, like we have been also planned to organize small competitions for the students and the kids as well, and the college students, and the scientific session as well, just like today. So today we are having Dr. KP Jayaraman sir, and I hope few people already do know about that. There is a very few people here. How many of you do know about that? So if you do not know about sir, let me just tell you. Sir has done lots of things. Sir is a science communicator, but sir was in BARC, Baba Atomic Research Center, which is India's one of the best institutions and the organization, if you do know about that. And sir, today we'll just take a kind of interesting session today again, as usual. And it's really privilege to have sir at our platform today. And thank you so much, sir, for joining us today. And thank you so much, everyone who is just joining here. Please continue session, sir. And if you'll have any issue, I'm here only, sir. You can just let me know. Please continue this session, sir. And once again, thank you so much for joining us in this series talk, sir.
Okay.
You are not
Thank you.
audible, sir. Yes, yes, audible. Yes, please continue, sir.
Thank you. Thank you for having me here. And I'm very happy and privileged to know the activities of the Indian Space School and the phenomenal work you are doing for the young generation, taking them, holding hands with them, and taking to the frontiers of science, kindling their curiosity, and making a truly scientific India in its full aspect. So I'm very happy to be part of this activity and to hold hands with you on this. When I was invited to speak on this platform, first I thought I will talk to you about what is happening in the field of science, what happened in the year 2026. Then I found out that we are celebrating the Space Week, and poetic justice demands that I should speak on a subject which is close to my heart and with which I have been dealing with for several years. I look backward in time. If I push the arrow of time backward into the 1970s, that was my first encounter with space science of India. Then space science was a toddler. We were having baby rockets, pencil rockets at that time, way back in 1970, February. I had been to one of the then advanced, industrially advanced countries, Japan, and spoke to the Japanese people and to the visitors from across the world about India's hopes, aspirations, expectations, and dreams on space science. In World Exposition Expo 70, Osaka, Japan. That has a still higher historic value. The father of India's space science program and space technology program, to which it evolved later, was Dr. Vikram Sarabhai. It was Dr. Vikram Sarabhai who inducted me to the science communication on space science. I was trained what is the narrative to be given to the world according to his dreams in full tandem with his views. And I was also taught Japanese language to talk to the people, in the language which they understand. So I can understand how a science communicator is reared in, nurtured, and brought into an exposition. I have gone through that exercise, and I feel very proud of that. Standing there in Osaka, explaining to the people of Japan and the world at large what India's dreams are. So I call this from Rohini to the new space age. Most of you may think, why am I referring to Rohini? Rohini is one of the mythological characters of India, and they are called Apsaras, the divine celestial creatures. And what has it got to do with the space? Because we are under the impression that space means somewhere outside the world. If you ask yourself the very fundamental basic question, where is space? Where does it start? Standing on the surface of the earth, you will think 40 kilometers? That's the height at which a balloon soars. Can we go beyond that? So somewhere, space scientists, atmospheric space scientists, have been dealing with the idea that space begins around 100 kilometers away from the Earth. That's the distance from Bombay to Ahmedabad. So vertically you are up, you are in space. So where is space and what is space? To the students of 6th standard and 7th standard, I want to ask a very simple question. We all learned what matter is because it's a material world, a material universe, a material cosmos in which everything in the universe is made up of matter. But in the 7th standard textbook, if you ask what is matter, you will find a standard definition. A matter is that which occupies space. A matter is that which occupies a space. So space occupancy is the factor of matter. So matter and space are related. That's how, from the school, we begin our introduction to space. Unfortunately, in our country, we study space much later. We study matter, but we study space much later. But if you look at the next generation science standards, which the United States has been following brilliantly and remarkably, they have physical sciences, they have chemical sciences, they have geo and space sciences, then they have engineering sciences. All their syllabus, all their textbooks, all their tutorials are based on this physical sciences, life sciences, geo and space sciences, and engineering sciences. That means right from the beginning, right from the middle school onwards, they are exposed to geo and space sciences. So that's the beauty. We are latecomers in the school to this subject, but that doesn't matter. Today we have enormous wealth of information as far as space is concerned, because India is one of the most powerful stellar figures in space research. So my encounters with space science, technology, and communication. I explained to you the space communication component of it. While I was working in the Baba Atomic Research Center, I was deputed and I learned the art and craft of communication first, regional native language communication, and then made my narratives weave around that and started my career as a space communication scientist. Now, you may wonder why we start straight away to space technology and space today, because it is high up in our mind. Right now, Dr. Anil Menon is moving around the earth high over the skies in the International Space Station. So that time, if you look back, all of us are aware that we have been products of technology. The first thing, our first encounter, our first meeting with science and technology is in the Industrial Revolution. That's about 1760 to 1840. This is what we call the Great Revolution, the revolution of the Mother Revolution, where steam that produced motion instead of our transportation sector. Power was given to us by liquid water getting converted to vapor. So water, when it is heated, became steam, and that steam gave a power which rewrote the history. Human history took a big leap forward because of the steam engine, and that is called the Industrial Revolution. So we were at that time itself, we should understand space science was also evolving. The foundations of modern physics, Newtonian physics, action and reaction are all equal and opposite. All these elements of fundamental space science were also part of the steam engine physics and chemistry. So after the steam engine, the Industrial Revolution won, it became Industrial Revolution 2. And Industrial Revolution 2 is what electricity has done. Electricity brought a new light to human history, brand new light, which was not available earlier. So the Industrial Revolution became the second verse, and humanity took a great leap forward. So after being leading a comfortable life with electricity, with light and motors and other things, we went to the third industrial revolution, which is called the electronics and computers. So electronics and computers brought a new dimension to our life. And this is what we call the third industrial revolution. At that time, there is also a strong connection with the space sciences. Electronics is the motherboard for most of the space activities. So you must understand between every industrial revolution, one, two, and three, the main spring that drove these industrial revolutions were nothing but research, scientific activity, technological activity. So it was scientific research which changed, which brought in the industrial revolutions, both one, two, and three. And the intensity and the speed with which scientific research was going on, it has brought us to the fourth industrial revolution today. And if you look at the face of the fourth industrial revolution, which we are all going through, we are both witness to and participant to in that great industrial revolutions. We have new materials around us. We have quantum technology. We have space technology. We have biotechnology. And we have sustainable, that is green technologies. So these new phases of technologies came because of the fourth industrial revolution. So in the fourth industrial revolution, we have reusable rockets, private space industries, we have lunar and Mars missions. Our whole concept of space has changed. We are thinking of neighborhood planets, and even we are thinking of solar expeditions. So that's the way space science has gone in. So we must now think that space science is at the bottom of our industrial civilization. And if you look at any newspaper, you will find a lot of space news. And there are journals exclusively devoted to space science and space technology. This is the historic picture that lingers in my memory. You will find Vikram Sarabhai here with his vision, foresight. And I was one of the ambassadors, space ambassadors, who narrated that vision to the rest of the people. That was, I would call this my personal journey. And this is what I call Rohini to space age. Let's begin with a very small story, because science stories, space science stories, make space events most memorable. Once upon a time, long, long ago, quite long ago, there was the first scientist whom history has recorded. He was called Thales of Miletus. He's a Greek philosopher. At that time, the word science was not there. There was science, but it was not called science. Much later, we used to use the term natural philosophy. So they were called philosophers. And Thales was one of the first philosophers recorded in human history. He was so fond of the sky, enamored of the beauty of the sky, and he was looking at the sky and walking. And as philosophers, there is a saying that he was walking glued, with his attention glued to the skies. He didn't know what was under his feet, and he was about to fall into a ditch. That has been recorded. Then somebody was walking along that, shouted, stopped, looked back, and prevented an accident which would have brought his life to an end. So that is the Thales story about it. If you look at the rockets When we speak about rockets, today we are thinking of the big rockets. But everything big has a small beginning. We all started with the pencil rockets, rockets as small as a pencil. Then they were called baby rockets. Then they were called sounding rockets. So rockets themselves belong to a big family. In fact, the first we were sending our rockets from the southern tip of India near Thiruvananthapuram, where the geomagnetic equator is crossing, and that place is called Tumba. It was from Tumba that we took our tottering steps to the majestic flight we are having on space sciences today. And also remember that the first rockets from Tumba were not made by us. We borrowed rockets to test whether we can absorb, make it part of our technology. So we did that. And the first rocket was an EK Apache 1, which came from the United States. Now, having done that exercise with the US support, we started standing on our own feet. We had our first rockets. Early Indian chapter was the Menaka rockets. So we started with that. Then we tinkered on it, we innovated it, we learned a lot of lessons from that. And from our mistakes and errors, we perfected our technique and we went to the next generation called the Rohini rockets. Now, why was it called Rohini? There is a lot of anecdotal rumors going around. We decided that we will name our rockets after celestial creatures, celestial concepts. And Rohini was the next one chosen. There is also a strong feeling among the space community of that age that Rohini was chosen as it was the birth star of the wife of a great scientist. So the name stuck, and we had the Rohini rockets. The first Rohini rocket, 75 centimeter diameter, red in color. I had the privilege of holding that model in my hand and explaining to the world, this is our Indian rocket today, but we have miles to go, and we went miles ahead. And look at the space scene today. We have the SLV in 1980, Satellite Launch Vehicle 1980. Now working with SLV, we came to augmented satellite launch vehicles. Augmentation means improving, adding, value adding, technology adding. So from SLV, we came to augmented satellite launch vehicles. Now, having mastered the technology of ASLV, we went to PSLV, Polar Satellite Launch Vehicles. That's where we went in next. Today, from 2001, at the beginning of this century, we went into geosynchronous launch vehicles. And we have heavy lift capacity, and we use advanced technology, that's a cryogenic technology for this. So if you look from 1980 to 2001, in 2 decades, 20 years, we have taken great leap forward from SLV to GSLV, which is one of the most powerful workhorses which any nation is legitimately proud of. So that gives you the history of the strength of our satellites. Oh, those names I mentioned to you, Urvashi, Menaka, Ramba, Tilottama, these are the names which school students learn. And only Urvashi, Menaka, and Rohini came into this picture. Yes. And before the rockets, there was a pre-rocket era. Then scientists were using balloons, very similar to the birthday balloons. Balloons go up. If you put hot air, it will go higher up. So the Tata Institute of Fundamental Research Scientists with Dr. Homi Bhabha and with Professor M.G.K. Menon, They were toying with the idea of understanding our atmosphere, atmospheric physics, humidity, temperature, ion characters, all these things with the help of rocket launching facilities, so with the balloon launching facilities. So the prelude to the forerunner of our rockets were the balloons. And we had excellent technology in our balloons. Our cosmic ray studies were conducted with this. And in fact, the most famous Baba equation on cosmic rays was that experimental data required for that came from balloons. So from balloons we went to rockets, from rockets we went to satellites. These balloons can go up to a height of 40 kilometers. As you go up, when the pressure in the atmosphere decreases, the balloons will bulge. You will get a more expansive space, and there's a payload or an instrument carried by them which will relay the data to the Earth. So that is the balloon era. Space science did not begin with satellites. It began with balloons. So these were the birthday balloons of the space celebration today. So at that time, I also had the privilege of visiting the space station in 1970. Like our Tumba, they had their Tumba, and that is called Uchinura. In Uchinura, they used to send balloons. They used to send rockets, baby rockets, but bigger than our rockets. So they were called sounding rockets because basically they were handled by scientists for scientific experiments. But the launch technology they developed, there was a precision and accuracy, the reproducibility, which they could master much faster. And rocket science and rocket technology was deeply ingrained in the Japanese science. So that was a young nation. And you can see some of the Uchinora station over here. It's a beautiful place surrounded by the sea, very similar to our Tumba. And then you will find one of their rockets lying on the floor. Then came the Sputnik era. That was an explosive revolution. The whole scientific community, why the scientific community? The entire humanity was taken for a shock when Sputnik was shot up into the space, and the Russians created history, and humanity also created history. In fact, its impact was so great that one pyrotechnic technician in Kerala thought, I should also send something into space. They thought that space technology and rocket technology is so simple. And he was making potassium chloride, ammonium chloride based fireworks, which we call pyrotechnics. And he had very high energy intensity pyrotechnic devices, which are called OUT, out. And on the top of one of his devices, he kept a dog, thinking that what the Soviet Union did can be reproduced in a small village in Kerala. Up went the out went the dog. So that was the tragedy of. But behind that, there is a story. The story is that when scientific achievement happens stirring scientific achievements happen, people like to copy that, not knowing the intricacies and nuances and the difficult equations and chemistry and technology that is behind it. So that is a story which is not recorded in history, but anecdotal evidence exists for this. Disturbing story, but a revealing story. But it shows how shock waves of Sputnik traveled across the world, including a small village in Trichure in Kerala. But there was a greater revolution, still not known to many people. When the Russians mastered the Sputnik technology, one man, his name is Dr. M.P. Parameswaran, he died a week ago, was attracted by this Sputnik. He's a nuclear engineer. electrical engineer turned nuclear engineer. He studied the Russian language and he found that the entire space science and technology is explained to the Soviet Russian people in Russian language. It was not explained in English. It was explained in their own mother tongue. So he found one of the major historic findings that to make science understandable to the people, we should speak their own language. And he started a revolution. We call it a revolution within revolution. And he asked 100 nuclear scientists to join together to start a communication revolution. So from the space revolution of the Sputnik came a linguistic revolution, that the language of Kerala, which is called Malayalam, which is a word is worth remembering. It is a palindrome. You can write Malayalam forward and read it backward. It is the same. Any English word which can be read forward and backward is called a palindrome. He made this language capable of handling the technicalities of space science and all advanced sciences. Now, languages normally are behind technology. A technology word comes first, then it goes to the people. And most of the languages have no language, no, even English language, have not developed the word first and the discovery or invention or innovation later. So he took an advanced step. That's what we call a revolutionary step. Let us coin 5,000 words in a language. 5,000 new words, neologisms they called, to reflect contemporary scientific terms. And a technical glossary was made and it was presented to one of the Indian languages. Nowhere in the world has this synthetic engineering of language accomplished thanks to a revolution which took place in space science. The Sputnik revolution and the linguistic revolution in one Indian language, and then multiplying it in the Federation of Indian Language Science Communications is an important thing. So today, when we are reviewing the glorious tradition of our space accomplishments and achievements, we should also remember the fallout of that. And some of the fallouts and byproducts are much bigger than the mainstream in terms of its long-term impact of science on society. Science and technology directly impact society. But beyond that, there is a much longer tradition of a scientific revolution. And he said, Dr. Parameswaran said, science for social revolution. Normally, those who are engaged in scientific activity, asking questions, curiosity driven, blue sky research, why is the sky blue? Why is the sea pale green in color? We ask a number of questions, fundamental questions, which led to the Raman effect. Why is the sky blue? Why is the reflection green? So this type of science, which was known as the early fundamental science, said all science should be for human benefit. Divorce from humanity's comfort and relief, science has no meaning. Science is for human beings and other living creatures. So that was a message which is a byproduct of the Sputnik revolution. Now, Dr. Sarabhai was, when he was overseeing the rockets, the satellites, he was also having much larger dream. What will it do for India? The millions of Indians below the poverty line, what can we add to the living conditions of these people? A satellite up in the space will not be giving food to the person on the floor. So there is a relationship. And finding that unseen relationship, that is where visionaries come. He knew that satellites can be used for weather forecasting. And farmers are at the cruel mercy of weather. They do not know, will it rain today or will it rain tomorrow or will it be a drought or a El Nino effect will come? They have no idea about it. Utterly clueless. He said we should be able to make reasonably good predictions about our weather, for which we need satellites. In fact, the farmers of Kerala they were trying to find out how the rubber plantation should be planted in which part of the time. Rice plantation. The entire agriculture is based on our ability to control not to control, you cannot control the weather, but information about the weather, advanced information. If you know it 1 week ahead, if you know it much ahead, in fact, it is your advanced information which helps you to prepare the field for seedlings, fertilization. Everything depends on that. So that was his idea. So remote sensing. And he could also find out that remote sensing, one of the most fundamental vital elixirs for life is water. It's all underground. We don't know. Underground means invisible. Which way the water table moves? What are the pathways through which water moves? So these are questions which have to be understood by remote sensing, weather. So that was one of his grand ideas. Sarabhai's idea, we must also remember at that point of time, in India's scientific history, the Department of Atomic Energy and the Department of Space were together under Sarabhai. And he had a larger dream combining the nuclear and the space, a nuclear space dream, which is called a nuplex. His big idea was India should produce enormous quantities of electricity by nuclear fission, by nuclear energy. That energy should be converted into direct products of agricultural yield. This is what is called his grand idea of nuclear powered agro-industrial complex. How does it work? We have a nuclear reactor where uranium undergoes fission, becomes barium and krypton, gives a lot of energy, and that heat energy is converted to cool. Seawater is used for cooling. The heat will be used for evaporating seawater. Seawater is salty. It contains 35,000 parts per million of sodium chloride per liter. If you heat that, only water will go up and the salt will remain back. That is called desalination, removing the salt from that. So Dr. Sarabhai thought that using a nuclear reactor located on the seashore will get it cooling water and will produce fresh water. And that fresh water will be the input for agriculture. And agriculture also, he worked with agricultural scientists, nuclear agricultural scientists, worked on different types of crops which we are using and developed high yielding varieties. So you can multiply the yield of our farm products by using nuclear radiation, atomic radiation for high yielding varieties. So reactor gives energy, it gives you water. Then you need fertilizers. Fertilizer, the most important fertilizer is ammonium phosphate. And you need ammonia. And to make ammonia, you need nitrogen and hydrogen to combine. And nitrogen and hydrogen are extremely reluctant to combine. You need high pressure, high temperature to produce ammonia. Making ammonia is one of the most costly processes in chemical technology. And therefore, unless you have extra amount of energy, it is not possible for you to make ammonia. He also had the great idea. So when we are speaking about science, we are going through the brain waves which Sarabhai used to have in those days. He said, we should have phosphorus. We don't have phosphorus in this country. What little phosphorus we have in the Rajasthan Udaipur is very low grade. Chemical engineers will not touch it with a pole. Very poor quality, low grade. Oh. So we used to bring rock phosphate from Jordan, which is a rich mineral. So we bring rock phosphate, then we bring sulfur from the Middle East, convert sulfur into sulfuric acid, then we add sulfuric acid to rock phosphate, we get phosphoric acid. That was the route, dependent both the raw materials, sulfuric acid and rock phosphate coming from abroad. And Indian farmers have to be critically dependent on that phosphate, to which he found a solution. He said, we have rock phosphate minerals which are poor in grade. What we will do is, we will convert this rock phosphate, put coal with that, an electrothermal furnace in which because we are producing electricity in the nuclear reactor, that nuclear reactor will give you heat and electricity, which will convert this rock phosphate into phosphorus directly as an element. From rock phosphate at that high temperature with silica and carbon, he could theoretically produce phosphorus. And that phosphorus you put in water, you get phosphoric acid. What a wonderful way, what a wonderful chemical route to produce phosphoric acid. And that was a grand dream of a great visionary of our times. So space science was one part of it. There was a nuclear Sarabhai, there is a space Sarabhai, but in Sarabhai, both nuclear science and space science merged in such a way for the benefit of the society. So if you look at the India's march to space, it started in 1963, and in 1975 we have Aryabhatta. Now, why do we name our satellite Aryabhatta? Ask yourself this question, and I would request all my academic friends here to look at Aryabhatta's origin and how he is connected with our space research. Then we have 1984, an Indian, Rakesh Sharma, went to space. Then we had the Mars mission. Dr. Radhakrishnan was working on the. We were looking at beyond the Earth to this. So then, in '69, Indian Space Research Organization came into physical being. Then I gave you the story of SLV-3. Then our Chandrayaan mission, Chandrayaan advanced missions, and from our national hope and aspiration, expectation, we came to national capability. Science answers questions, engineering delivers the goods. Space goods and products were available in India as a result of the application of space technology. Then the world was watching us, and we were visible, both in terms of space accomplishments, and they said, we will hold hands with you. So global space participation in anywhere in science and technology, it is a team which achieves more than the sum of the individual contributions of the individual countries. That is why NASA is keen on collaborating with India. And India also, it's a mutual collaboration. It's a benefit of both. That's what we call synergy and collaboration and cooperation. And usually collaboration happens between equals or near equals. And that is why today we can proudly and legitimately stand up and say, look, I want to hold hands with you because I have material of strong stuff. That's where we stand as far as space science and research is concerned. So this is our Chandrayaan 1, Mangalyaan, Chandrayaan 3. Can India reach space? And how far India can go? Sky is the limit. Today we can very clearly say, in fact, the expression sky is the limit finds a meaning today thanks to India's achievements in space technology. So we look beyond the Earth. Firmly founded here, we are reaching out to the space. Now, from the laboratory, science and technology should go out. We build strong defense strategic capability, which we call a national asset today. In the defense sector, in the strategic sectors, and now we are thinking in terms of we should not do business as usual. We should do business in an innovative, brand new way. So we start startups, that is path-breaking, pace-setting activities, ideas, incubators, technology business incubators. That is what science has produced. As a result of research and development, in fact, we normally follow a method called RD4, research and development. I want the new generation to remember R&D, R&D, R&D. That's a mantra which we have been chanting heavily, R&D, R&D. Look at the anatomy and physiology of R&D. You can write R&D in 4 ways. You write a small r and a small d. You write a capital R and a small d. You write a small r and a capital D. And you can also write a big R and a big D. Each one shows 4 different mindsets of a scientist. Some people do a lot of research, 6 hours in the library, and development very small. Some people, very energetic, enthusiastic scientists, they'll be all the time in the laboratory, developing. They will do little of what others have done. In science, we should stand on the shoulders of others. Einstein stood on the shoulders of Newton. Hawking stood on the shoulders of Einstein, because we internalize, we make it part of what they have done. So R&D means research and development in equal proportions, capital R and capital D. But it is not enough if you do research and develop something. You should demonstrate that. It should be reproducible. What I did as development, I should be able to get it reproduced, that is validated by others, or at least I should not be falsified by others. That is called demonstration. Okay, you did research, you did development, you also did demonstration. What next? For society, deployment. This is the RD3 formula which Dr. Anil Kakodkar was mentioning all the time. Research, development, demonstration, and deployment for the benefit of society. Then only that cycle is complete. Think of that. So from national capability to global collaboration, but national application. Startups. Okay, you do a startup, then you need to scale up. Industry should be able to produce. The supply chain and logistics should come into practice. So the benefits of your startups, the products and services which you develop are available throughout the country. So industry should take it up. Yes. Now let us just think about Dr. Anil Menon, who is orbiting the Earth right now. Why did a neurosurgeon go to space? Or what are the essential qualities for an astronaut today? There was a time when it is your courage, your adventurous nature, your physical stamina, your ability to withstand stress, and your ability to be adventurous. Those were the basic driving force for an astronaut. Today, those who are trained on the sensitive elevations of sophisticated science, neurology, cerebral sciences. So Dr. Menon, Anil Menon, is now in the International Space Station, and he will study. Look at from our laboratory. The space has become our laboratory, and we will study blood and circulation. What happens to the platelets? What is the viscosity factors affected? So that is blood flow vessels, blood composition under a condition which is creating on the surface of the earth is difficult. So microgravity has given us an entirely new branch of studies, and that's what being studied. Vascular health is being studied, exploring vascular structures, and we will do medical diagnostics well high up in the International Station, and medicine from research for producing fluids for water. A number of programs have been designed, carefully curated, and are being put into action there. And the big question is, how do we keep a human being healthy, not only on earth, but high up in the air? Oh, this is Anita Sengupta was recently here, it was some time ago. We thought that the best way of science communication, taking to young, very young children, I wanted her to speak to them so that they get a taste of the person who has been there, and authenticity, credibility. comes only when the person who has gone there speaks. We can pick up a lot of information, and today we are suffering from overload of information. But credible information from authentic sources, a typical experiment in science space communication was conducted by me by taking the astronaut to speak to children directly. Okay. One of my favorite topics is water and wastewater management. I spoke to you a short while ago about desalination. And we have been thinking about a desalination. And now, right now, country like Singapore and Middle East, there are large desalination plants. In fact, during the Iran-US conflict, we found that desalination plants were targeted because what drinking water is stopped, the life will be paralyzed. So we know that desalination plants have become vulnerable targets in modern warfare. But if you look at the microchemistry of that, converting urine into drinking water, that's what space science demands, because you can't take all the water for long stay over there. So we do reverse osmosis methods. They have advanced membranes, not the old cellulose acetate membranes, the polyamide membranes at the appropriate pressure, so that we have a circular economy. The full concept of a circular economy is a product of space science and space technology. These are the women who have gone to space. There is a famous saying that half the sky belongs to women. That's what Mao Zedong said. But the space science has brought a revolution within revolution by sending women astronauts to space, and they have done wonderfully well. That's something of historic value to us. A short while ago, I mentioned that nuclear and space were together once upon a when in the initial days. Now the question comes to us again: can we use nuclear propulsion for our space research? That's a question which is going through our minds. Right now, we are using chemicals for high thrust, and I understand that scientists are working on nuclear propulsion systems, and nuclear scientists are looking ahead. Okay, let's go to one slide which is of interest to us. If I study space and space science, what job will I get? Now, when we are in the threshold of academic education and we choose fields, and space is an attractive proposition before us, do we have a space in space research? Well, yes. The Department of Space, ISRO, and all over the world, the space programs have enormous opportunities for scientific development and personal development and professional development. If you look at the applications of space scientists put out by ISRO, you will find aerospace, aerodynamics, propulsion, cryogenics, avionics, structures, thermal systems. Engineering is of extreme value. In fact, space science is largely an engineering affair today. Then, if you want to do space research as a scientist, you can be a space scientist, a research scientist, and you can work on astrophysics, physics, chemistry, cosmochemistry, origin of life, how the first molecule of hydrogen cyanide was formed, enormous possibilities, planetary science, materials, new materials we require, project scientists, research associates, data scientists, operations and mission, manufacturing and quality, and then space medicine, which Dr. Anil Menon will be doing path-breaking, pace-setting experiments. The space is no longer just rockets and astronauts. It's we, the young generation, can find bright glorious career in space sciences. I will conclude with a story which Kalam used to tell me. And one of his fascinations was tell science stories to students. This is one of his very favorite stories. And while we were traveling from Trombey to Gateway of India, he narrated this story to me. And nostalgically, I recall this story. There were two frogs, identical, and there were two half filled milk glasses. Each is a thought experiment. Both the frogs fell in. One made a few movements, accepted its fate, and remained there, dead and gone. Other one jumped up and down, created a lot of kinetic motion, made froth around it. The level went up, it got out. I am not discussing the fluid mechanics of this, but what Kalam was saying here was continuous, sustained, constant effort, single minded devotion, perseverance. That is essential for survival itself. That is a very powerful message which he narrated through this half filled milk glasses and the two frogs story. It's morally strong, and he passionately narrated the story. And I still remember the vivid details in which he stated his science story. Science is taught at early childhood education in the primary classes with stories. Indelible impressions will be created. And later, when they go to higher classes, you will find resonating reflections of this. Well, with that story, I stop my science storytelling on space.
Good evening, sir.
Yeah, so I have taken you through a wandering journey through the space research from 1970 up to today with the interactions I had with the space heroes of the times. If you have questions, I'll be very happy to answer.
Yes, sir. So I'm a part of the ISC, sir. So I'm the part of the Indian Space Club, Space School. So if anyone has questions, you can ask them, or you can put it in the chat as well.
Okay, may I go first?
Yeah,
Yes,
sure.
please.
Okay, yes, sir. Myself, Raif Ahmed Khan, sir. I'm speaking from Maharashtra, Akola. I'm currently studying in 8th grade, Mount Carmel High School, Akola. Yeah. So I had three main questions actually, and the first one was, by your experience and your analysis, if there was a space race that were to be begin in the next in the next 10 years, what who would be the most competitive countries against India in the space race, and what should India do to beat them in order to survive and beat them in this space race? That is my first question, sir.
So
Thank
we'll
you.
answer the first question first. Why do you think there will be competition after 10 years? Think of cooperation after 10 years. And nobody will be fighting because fighting doesn't help us anywhere. Space is an area where collaboration, international collaboration. Think of the International Space Station, the Russians and the Americans and the Indians. Right now, ISS is a classic example. So, competition has no scope in space research. And as we go forward, we'll be cooperating and collaborating more. So, please take out the idea of competition and becoming first, second, third. That mentality, let us take it out and think of only a cooperative, collaborative world. Next question, please.
Okay, so my next question would be like this is the age of AI, and right now it is the singularity. Singularity means that when AI is smarter than humans, at this point of when we humans stand, when AI is smarter than us, what jobs and what position of jobs do you think would be the first that would be replaced by AI, and what should we aim for?
Good question. Let me ask you a question back. Who created AI? It is a human brain.
Yes, sir.
It is a product of cerebral thinking of man. It is a tool for us. When we couldn't reach a mango with our hand, we took a stick and took it out. It was an extension of the human brain. And therefore,
Yes.
we will be able to think better. And there will be jobs which were doing were more time consuming, laborious, and monotonous. That will be handed over to the AI to do that. You will get better materials to work with. In fact, humanity will take a quantum jump forward with AI as its, I would say it's not a master slave. If you think of a master slave manipulator, we have got an intelligent slave with us. So the master will still rule. So humanity, human cerebral neurons cannot be replaced. The electrons of the chip will not replace the neurons of your brain because these electrons are products of the neurons of the human brain. So artificial intelligence is a useful ally, a powerful ally, and it all depends on how intelligently you use this artificial intelligence. Next, please.
Okay, sir.
So one more
Next
question.
question is actually how can AI help us, and how do you think how much will we advance using AI, and what, like, is there any specific positions at the ISRO or at the space organizations that AI would be very useful to in for us?
Yes, AI will be exceptionally helpful when you have a large multitude of data and you want to find meaning in data and you need potential correlations, what we cannot think of by processing data, cleaning the data mining, data cleaning, then processing the data and finding out alternative solutions. The limitations of human thinking, you will go beyond that and you will get an input thought from the artificial intelligence and on which you can work upon. So you will be in a higher position of thinking. I think, therefore I am. I think with an AI, therefore I am. I think bigger than what I thought. So that is the
For
state.
cogito ergo sum, yes. For cogito ergo sum, I think therefore I am. René
Yes,
Descartes,
I
yes.
think therefore I am, that cogito ergo sum. That's what the philosopher said. That has got a new meaning today thanks to AI. Initially, there will be a lot of information coming. There was a time when computer came that all people will be jobless and all that. But these are all transitions. Dull and dirty jobs will vanish. More
Yes, sir.
intelligent, refreshing jobs will come. So a brighter future waits for you. Don't worry.
Yes, sir, I know that. Yes, AI cannot replace jobs, but it
Not
will
at all. It will never
replace
replace
those who
you.
know to use.
But you will
Yes, yes, it
absorb
will.
more AI. You will absorb greater
Yes, thank
skill.
you, sir. Okay.
Yes.
Yes, sir. Thank you.
Thank you. Any other question? Yeah, there is.
So I had a question.
Yeah. Yes, I see. From Minu Compose. Sir, I am postgraduate in instrumentation. Yes, instrumentation, that is the nerve center of modern technology. If you don't have control rooms, whether it's the cockpit of the pilot or the control room, the nuclear reactor, you need instrumentation. You need instrumentation reliable, precise, accurate, and you need a triple redundancy of instrumentation so that you don't go wrong. So every technology is dependent upon your instrumentation, measurement, accurate measurement, error, precision, accuracy, and converting it into numbers. The literacy which instrumentation provides is the means of controlling it. You know a situation only if you understand it. So, as an instrumentation tech engineer, you have enormous future. Many fields are getting in. Look at instrumentation required for robotic surgery. You need instrumentation of different dimensions today, because as technology develops, you need instrumentation of a more sophisticated nature. It's all part of it. It's a growth in toto. Is that make sense to you as an instrumentation engineer? Yes, sir. Yeah, yes.
Anyone else? Questions?
Yeah, I have. So I have a question about wastewater. Like, how do we achieve closed loop or zero waste recovery without relying on heavy consumable filter replacement or exclusive energy from Earth?
Very brilliant question. Never allow water to become wastewater. But we cannot live without making wastewater. The moment you take a bath, the moment you wash your hands, that good water has become bad water. So a water becomes wastewater because some impurities other than water molecules are present there. So there is a branch of science called a separation science. In separation scientists and technologies, their business is to separate those contaminants outside. Now, there are several technologies available today, but one of the most promising today is called reverse osmosis. It's a membrane separation process. That membrane technology is capable of separating. For example, if you have 1 part per billion of gold in seawater, 1 part per billion, and it is an impurity in seawater, see. So we want to remove that impurity to make them a valuable product. It is possible for us to use membrane technology to take small quantities from huge dilute solutions. So membrane technology is the in thing as far as water and wastewater technology is concerned, and they go together. Earlier they were teaching water technology, purification of water. Today we speak about when you purify water, you get constant. If you are doing the seawater desalination or brackish water desalination, you will be getting a concentrate. That concentrate is a mineral concentrate. If you can separate that out of it, you will get in the for that's what the whole concept of circular economy depends on that. Then again, there are existential situations, as I told, that urine is material available in space stations. You have to convert it into potable, safe drinking water. That's being done by osmosis, by RO technology. So, water and wastewater is one of the most promising chemical engineering problems now, and advanced technologies are available for this. And that's the way there are huge desalination plants are there in Singapore and the Middle East, because we need 8 billion people should drink water every day.
Sir, I think following up on Mino's question, sir, she says that she has deep interest in astronomy too. So she's asking how she can further move on because she feels a lack of knowledge after a 4-year study gap.
See, astronomy education depends on your strong physics. So if you do your BSc physics or your MSc physics, you can have an elective paper in MSc on astrophysics or astronomy. Then you have the IUCA and several universities now who are giving courses at master's level. Then you have the observatories where you can get. At a lower level, if your interest is of a general science communicator, you have the planetaria available for explaining the content to students. So the level of, if you want to do advanced research, then you must join advanced universities where they do astrophysics. You can do work in CERN on particles of it. So it all depends on astrophysics at a very high, or fusion technology, the combination of hydrogen deuterium ions, tritium ions high up in the sun. So astronomy and astrophysics give you enormous opportunities. Cosmochemistry is also part of that. So the frontiers of knowledge depends upon the background to which you have elevated yourself. So if you are strong in your physics and strong in your chemistry, and you have the right guidance, right equipment, and the right ecosystem in which the research is to be done, because every research should produce results which are self-satisfying, professionally rewarding. Otherwise, you'll get frustrated. So if you want to be on the frontiers, you should be in the right place with the right people at the right time. So look for it. There is always a right place and a right quality for that. Keep your eyes and ears open to all research possibilities.
Anand, I think you have a question. You can go on.
Yeah. Where is that question?
Yes, sir. So I'm currently studying in UAE. I'm in ninth grade, but from after 10th I would return to India and all. And I'm really inspired about astrophysics and everything. So once I did it for a school project, but then now I'm really passionate about it. So how can I improve my interest and make it to something that it could help my future? Like I thought about buying a telescope, but then realized that in UAE, due to light pollution and all, it won't be really clear. And I'm from Kerala, so in Kerala, it's mine is like a village area where there is a lot of trees and you can't get a good view of the sky. So I thought about like researching a bit, and I also have one other question. So, like, is fundamental physics, will it depend more on building larger laboratories or like how to learn about the universe? Because many of the inventions were found from neutron stars, black holes, or supernovas, including the dark energy and dark matters, by understanding how they interact with other elements. So, I would like to know the answer for these two questions.
Nice to know you have a stock and inventory of very intelligent concepts with you. And since you are from Kerala and from a village and there are lots of trees and coconut trees around, you can always find a hill or a hillet on top of which you can go. There are nearby about 5-6 kilometers away from every village, there is a small hillock. So you can go and put your observatory from over there. You should also visit planetaria around, because this is a stage where you should get heavy exposure to planetaria, simulated planetaria, the new ones. So that will sharpen your concepts. Then, regarding the question whether you need huge investments like CERN to do your research, yes, there are people who are doing it in CERN. But you must remember, at theoretical physics, the work which Stephen Hawking did on black holes, it was not done on experimental basis. It's a theoretical physics behind that. Then you go into practical physics. So again, the area you choose depending on the availability of equipment or the availability of a professor who is an adept in that skill. So that's a bit early to predict now, but keep your interest alive. Visit planetaria. Visit universities where there are courses. There are master classes being given by NASA. So attend to all those lectures. And today the Coursera also will give you introduction to some topics. So keep your interest alive. Calls against film you see, and keep your interest alive. Curiosity should not be quenched. And as you go forward, now you're 9th standard, 10, 11, 12, your options you will be concentrating on some area. In fact, if you have 10 dreams today, as you reach your graduation, it will be 8 or 7. So when you do your graduation and you look forward, then you will have 2 or 3. So it's not that we carry a big basket of dreams. As we go, we know the difficulties and our limitations matching these two. By the time you reach graduation, but keep your interests alive. If you are passionate about a subject, read it up. You get Kindle editions of all the good books. Keep yourself, and also try to be in touch with people who mentor you to these topics. It's always good to find a retired scientist as a mentor for you, with whom you can have a dialogue and a conversation and a chat, which will help you in good mental health.
Okay, sir, thank you.
All the best to you.
Thank you, sir.
So I think Anmol, you can go ahead.
Yes. Two participants raised their hands, right hand or left hand? Both are
Anmol,
welcome. Yeah.
Anmol, is this audible?
Yes, very clear.
Okay, so I think we are not able to hear them. And Ria, you can go ahead.
Go ahead, go ahead. Shoot out.
Hello.
Yes.
Hello.
Yes, I can hear you.
Good evening, sir. I
Good
want to
evening.
ask if you could safely stand on any planet or moon for 5 minutes, which one would you pick?
Repeat your question. Repeat your question. Which planet?
Could safely stand on any planet for 5 minutes, which one would you pick?
The entire universe is hostile to me. Flesh and blood.
Yes.
I am
Oh,
in flesh and blood, and I am in gravity. So the limitations of the human body is so high. Even a spacesuit may not be able to help me. So I should not think of such suicidal efforts.
oh, okay, sir.
Live well comfortably on Earth now until we colonize Mars and make it a habitable planet. At the moment, they are all inhospitable and uninhabitable.
Sir, if just imagine if you can stand safely, then which one will you choose?
Then I would go to the nearest neighbor.
Okay,
Salvage the
sir, that's
friendly.
a nice choice.
Good neighbors, yes.
Thank you, sir.
Hello, sir. I'm audible.
Yes.
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 Sir, I'm Anmol, a class 11 student. Now, my question is that what you think that it is a major problem in nuclear science today that we can understand theoretically, but when we go to solve it experimentally, so we can't. What breakthrough would be needed to solve it, according to you?
Which is the topic of the problem between theory and practice? What was the problem on?
Like major problem in nuclear science today.
Oh, there is no problem in nuclear science. The problem in nuclear science, in the technical term, a problem in science is a difference between what is and what should be. I know the atomic structure to some extent. I know the nuclear structure, but there are baryons to be understood. There are other areas I need to understand. But that doesn't mean there are problems. For example, if you want to do an experiment, then I can do an experiment with the Sarangov radiation. So experiments may have their limitations. That is why you use theoretical models. Now, the correspondence between a theoretical model and the experimental results, the congruence between the two, that is what validates your models. So, in science, you'll always find an equilibrium between theory and practice. Einstein's theory has to be validated much later. So there is a theoretical understanding of a problem, which is a cerebral activity. Then there is an empirical activity which validates, empirically verifies this. So science is a mixture of the two. Some are pure theoreticians, some are pure experimentalists. So this equation between theory and practice is what makes science move forward. In fact, science is the only profession in the world where you can say, I am wrong today. No one else will tell you I am. If a doctor comes and tell you I am wrong today, they will not. It will not work. Science gives you the freedom that what I did today, it has been disproved by somebody, and I should have the intellectual honesty of accepting that my results were imperfect. So science is a search for perfection, and we will have to jettison and get away with some of our old things. Not just because they are old, because there are more things coming up. So that's the relationship between theory and practice.
Okay, sir. Thank you.
So I think there's a quite few questions from people up. So there's a question from Dave, which says that as India moves towards reusable launch vehicles and human space flight, what do you think will be the biggest technological challenge for ISRO over the next 10 to 15 years? And how can students like us start contributing towards solving it?
Yes, reusable rocket vehicles, new materials, the kinematics of it, and what is the propulsion technology you should use. And the whole world will be going for reusable ones because there is a materiality for space sciences, and materiality should be as low as is possible. So this is on the anvil today, reusable launch vehicles. The engineering problems will be solved by not by one engineering. You will have mechanical engineering, metallurgical engineering, chemical engineering, all together. The engineering sciences, that's what we call. They will merge and they will solve this problem. There is no single solution for this. But that is high on the agenda of contemporary research projects.
Next question, it's from a student called Vaidik. So he asked that we currently have quantum mechanics describing the microscopic world and general relativity describing gravity and space-time, but they're fundamentally difficult to reconcile. If we eventually develop a theory that unifies them, do you think it would merely give us a deeper mathematical description of the universe? Or could it fundamentally change our understanding of what space time and even reality itself is? And do you think such a breakthrough would reveal the concepts like space and time are not fundamental, but instead emerge from something deeper?
Very fundamental, absolutely fundamental question for which a theory of everything, putting everything together into one, has been the dream of scientists for a very, very long time. But if you take quantum mechanics or the quantum concept itself, look at the Schrodinger cat. Now, Schrodinger cat, we are all aware of cats. But can you think of a thought experiment in which a cat is dead and alive at the same point of time? That is what quantum science wants you to have a mental picture of. So we have conceptual difficulties because we have not been trained to think of a dead and alive cat together. So we have a thought experiment on that. The ultimate idea is like the elixir or the philosopher's stone of olden times. All sciences should come together into a unified concept. So string theory is trying in that way. Quantum sciences are trying to do that. So it is an amalgamation of sciences, the singularity of the origin of the universe. They are all thoughts today. But it is these thoughts which enable us to design experiments in support of that. Given the current state of research, we are not anywhere near a unified theory of everything. So I would leave it at that stage because in science you can't make predictions as astrologers do. But if you see the state of the art of science today, particularly in physical sciences, theoretical physics, there have been great minds working on it. Large number of experimental facilities are coming up. CERN itself is a classical example. So wait, don't give the final judgment today on a space lecture. Read all the journals you can, particularly on theoretical physics, and that will keep you sharp for a conversation among your colleagues. Space, warp, continuum. These are concepts with corresponding mathematical expressions. Space-time continuum. Now, if you are on the frontiers of this research and if you are mathematically gifted, you can probe some of the variations of these equations and make physical extrapolation from your derivatives. But at the moment, at the school level or even at the graduate level, I wouldn't suggest this is a problem to be done for a PhD. A postdoctoral work in centers of excellence where there are schools of thought on this, that would be the right place for you to work with. Picking up a few points, getting enamored of them, not able to translate them into reality, that should not lead to disappointment and disillusionment. Now, intellectually speaking, we have the freedom to choose any topic. But that freedom should have its constraints. Every freedom has its constraints. There's nothing like absolute freedom. So the problem which we choose, the schools of thought to which we belong, and the mentors with whom we work, that will decide the application of a specific problem. Keep general interest on the topic at a graduate and postgraduate level. And after a post-graduation, you can think of those areas where you want to dive deep.
Sir, I have a question personally. I feel that the younger generation, mostly students or high school students, are very interested in pursuing science and space science at high school itself, or are looking for opportunities or research opportunities. So I wanted to know from your perspective of where you've been and your experience, what are the opportunities do you think are there for high school students? Because most of the opportunities are either for UG or PhD or even PhD students, but not many are there in India specifically for high school students.
Well, as far as high school students are concerned, they can only do modeling or they can test some of the concepts in space science. They can even design satellite experiments for the department. So you can keep your interest alive by participating in innovative experiments, designing them. And that design will definitely have involved your teachers. So that is why geo and space sciences are being taught in the United States in the next generation science standards. And we find a large input of space sciences coming from high school students. In our case, our syllabus doesn't give emphasis for that. So most of the countries, a 14-year-old child, that's what the program International Student Assessment looks for. The PISA student has a science capital. And in that science capital, geo and space science is an important component. And they should be, most of our experiments are on water, wastewater, extraction of plant pigments. Beyond that, we should be able to think of an experiment which can be recommended to ISRO, and ISRO should take it up and send it to satellite, get the results and bring it back. So our involvement should be look up to ISRO, space agencies, and do an experiment, a doable experiment, give it to them and be part of it. And once you taste success, it's contagious. Then you will delve deep into that.
Thank you, sir.
Sir, can I ask one more question?
Yes. Is this the last question?
Yeah, so I think with
As-
this question, we can
Questions
close
are
the
very
floor for
interesting.
questions.
Probably overnight we'll continue like that.
Yeah.
Okay, sir, I had one personal question that which type of extracurriculars would you recommend to someone who is trying to get into Ivy Leagues like Harvard to study astrophysics and space science? As extracurricular activities which will help us to build our experience and get us into higher leagues.
So your destination or goal is an Ivy League institution. Am I right?
Yes,
Your
sir, mainly. Yes, sir, mainly.
Yeah. And for entry into the Ivy Leagues, it is not necessary that you should have specialized knowledge in one area. You should
Yes, sir,
have,
I know that. Yeah.
so you should have a wide spread spectrum of interests of a higher order. So higher order thinking experiments in, if you can translate one contemporary state of art topic into a project and get some data, is not enough you just do it. That will definitely attract the attention of the admissions of the Ivy League. It also depends on, you can't start it overnight. You should have an ecosystem in your school or a college where such facilities are available. If you are, whether the CBSE system or the IBDP or SSC, each one has its own mindset. So those who are in the IBDP system, their higher physics and their higher chemistry and higher biology demands a certain amount of experiential product. That itself will be good enough. So there you can choose a topic within the curricular system. I'm not referring extracurricular. Be
Yes,
strong
yes.
in your curricular.
Yes, sir.
And being strong on your curricular, you take one foot forward to your extracurricular. Which
Sir,
should
what
be,
do you think about
yeah, tell me.
what do you think about what do you think about AI, robotics, and computer science and astronomy as a a subject of interest?
Yes, they are the fashionable topics of today. But here you have to narrow down into a micro problem. AI is a
Ah,
large field.
yes.
Where are you going to apply? Are you going to apply or to find out how AI is applicable in diagnosis with the help of doctors? Then you should hold hands with a doctor and how it is useful to him in diagnosis. You can also
Hmm.
ask your own teacher to find out how the lesson plan for your physics was done with the help of AI. So applications, you have to think of that. I'm not saying you should straight away plunge into coding mechanics. Try to identify a problem. And remember, a problem in science and technology is very different. A difficulty is not a problem. A problem is something whose result will change our understanding today. So, what you know today, what you do not know. So, this from the known to the unknown, that is where your research comes. If a known problem comes and solutions are known, it's not a research problem. You are not here to validate somebody's question, although validation is a scientific process. But if you are falsifying somebody, contradicting that the experimental setup is not right, and finding fault with others in science is a good habit. A skeptical scientist should have. So when you hear words like large domains AI, quantum sciences, narrow down to one doable area. From a large
Yes.
canvas, you should come to all problems are atomic, not molecular. You find a large molecule, a charming molecule, a huge one, but you have to study one atom of that, part of it. The whole can be built only from the parts. So all research should be on a small scale, answering a one small problem. That might give a two, three more problems. Then you attack. So that's how the solutionist approach to science moves. So the research methodology and mindset will come as you start reading up how others have done research, how a standard typical research project is done. And now you find school students also doing projects. Read their projects, understand them, and better them.
Thank you, sir.
I think here we come to an end, like, so we can close the floor for questions. Or like you said, I think it's gonna keep going. So I think everyone can switch on the video so we can take a photo, like a screenshot, so that everyone can be seen.
Is that screen visible that way? No.
Yeah, one second. Let me just remove spotlight. So is everyone visible?
We are visible.
Everyone, please turn on your camera. And thank you so much, sir. It was really wonderful session. And thank you so much for the timing, sir.
I enjoyed speaking to you and I enjoyed your questions.
Yeah, definitely, sir. I'm just gonna call you for my grade first to fourth standard student, and those are really curious.
Very happy, and I'm glad that Indian Space School conducted this, and I got the most brilliant questions here. Yes,
Thank you, sir.
great. All the best to all of you in your academic journey. All the best.
Thank you, sir.
Thank you. Thank you so much. Thank you so much, everyone, for joining. Okay, okay, sir. Bye. Good night. Good night, everyone.